Hi, I wanted to give an explanation of essential question number 7 from the fall of 2011. So let's go ahead and take a look at our diagram right here. What we're looking at is what appears to be a constant series along here, another constant series right around here, and then what we have is this segment right here. It just looks like a geometric gradient. So you can see that it doubles each time, going from 4 to 8, 8 to 16, 16 to 32. So there's not a whole lot of overlapping here. There's just some time shifting going on that we have to cope with. So let's go ahead and start writing this guy out in factor notation, starting with this constant series right here. So what we're doing is we're looking for p. We have a constant series that's too high, so it's 2. Looking for p, given that we know a. Here's the interest rate, and we'll figure out how to handle the time shifting in just a tad. Then we have another constant series right here. So this is one which is minus 2. So we're looking for p, given that we know a. Here's the interest rate. And we'll figure out how long it is in the time shifting in just a tinch. And then finally, let's go ahead and deal with that geometric gradient sequence that's right there. And so here's one where it starts at -4. We're looking for p, given that we know a sub 1 should be a 1. We know the growth rate is 100% because it's doubling. Whatever the interest rate is, we'll figure out how many there are, and we'll also time shift this guy around. Sorry this is so sloppy, I'm kind of dealing with a new program at the same time. So let's deal with this first constant series. There are 1, 2, 3, 4 of those. So what we're going to do is we're going to pop a 4 in right here, because it's 4 long. And then the other thing to notice is that you see, last time you see a value is right here, and that's in time period 3. So it's 4 long. You need to make it so that the n and the exponent add up to 3, so that you know that this has to be a -1 right here. So that's effectively the 0 for that sequence. The next segment up here is the one that is -2, so there are 3 long right there, and the last time you see a value is in time period -6. So the 3 long, you know that you go ahead and pop a 3 in right there. And because you know that the last time you see it is in time period 6, you have to make this n and the exponent right there add up to 6, so you just pop a 3 in there and everything should work out fine. The last little component is this geometric gradient that's right here. So this is the one that starts at -4 and then doubles each time. So there's 1, 2, 3, 4 of these. So we can go ahead and pop that down into our equation. 4. You don't have to add 1, that's only for the linear gradient. And the last time you see one of these values is in time period 10. So what I'm going to do is I'm going to pop a 6 in for that exponent. 6 plus 4 is 10. And if you look at it, popping back up here, if this part right here is where negative is where 1 is, the one just before it, 6, is where 0 is supposed to be. So there's the 0 for it, there's the 1, there's the 2, there's the 3, and there's the 4. So that should make sense for that equation. So there you are. There is the present worth of this series right here using factor notation. This was essential question number 2, version 7 for the fall of 2011.